Hello, facilities management staff, school board members, and people from the community. We are RBBM, and we will be presenting our final report for the water infiltration issue in the utility tunnel of the elementary school. My name is Daniel Reardon.
I'm Frank Bierman.
I'm Graham Markert.
And I'm Joe Bakken.
So the purpose of this project is to examine and investigate the issue of water infiltration in a utility tunnel of an elementary school. Mr. Benjamin Leakey, head of the grounds and facilities for the elementary school district, reached out to RBBM and explained that the floor of the tunnel floods every time it rains, ever since it was originally constructed 6 years ago. He also explained the possibility of mold growth. RBBM was then asked to present our findings to the facilities management staff, school board members, and people in the community. We have provided details about the investigation process, remedial recommendations, construction background throughout the presentation. So our procedure started with a review of structural plans. We started by looking at the tunnel design, construction details to ensure that the proper materials were used, that they were installed correctly, and that they are compatible with each other. We then looked at the sump pump design and made sure it was placed in an area with high water accumulation. The external grading had to be evaluated to see if it directed water away from the tunnel. We also compared as-built drawings with the original design to determine any changes that may have impacted the structural integrity of the waterproofing. Utilities were evaluated where they were present or where they penetrated the tunnel structure and that they were sealed correctly. And finally, reviewed the air circulation and ventilation used to minimize the amount of moisture buildup. Our next step in the procedure was interviews, where we had interviews with Mr. Benjamin Leakey and the maintenance staff to help us understand the frequency and severity of the water infiltration. Then we interviewed the school staff to see the impact on operations due to the leakage, such as HVAC, electrical lines, and cables. Maintenance staff was also asked about any maintenance, inspections, or repairs done in the tunnel to understand the tunnel's history. Finally, we asked for input from the architect and contractor that originally constructed the tunnel for what repairs they think should be done based on the structure, waterproofing, and drainage that they had originally worked on. The biggest part of our procedure is testing. We started with an initial walkthrough of the tunnel to see if any obvious spots of water damage were present. Moisture meters were then used to measure the moisture content and where possible infiltration points were located. We conducted a water hose test where water was sprayed around potential infiltration areas that allowed us to identify leaks or weaknesses in the building envelope. We also conducted a flood test, which simulated a flood and allowed us to see signs of water infiltration around the joints and cracks. Our final test was an absorption test, tissue paper to see how much water had been absorbed through the walls. Finally, we documented and recorded our findings. The last step of our procedure is remedial recommendations, which we will discuss later on in the presentation.
And so moving on to some of the existing conditions and deficiencies, we're focusing mainly on the existing conditions that are contributing to the water infiltration in the utility tunnel. The primary issue identified was damage with the waterproofing membrane, especially at the footings where it wasn't properly wrapped and taped. This caused significant leakage at key structural points in the tunnel. Another major issue was the grading inside the tunnel. It was designed to have a 1/4 inch per foot slope to direct water towards, or rather away, but this was not properly executed, leading to water pooling at the center of each tunnel. And another issue was subgrade drainage systems were found to be clogged and damaged, preventing effective drainage at the location of the concrete downspout, as well as additional water flow right towards the tunnel, which only worsened the existing conditions. Moving on to the water membrane damage, as we referenced earlier. The membrane is the primary defense against water intrusion, and when it was installed in this tunnel, it requires a flat, continuous surface that is free of protrusions. The membrane was applied on top of the concrete layer that we can see as the tradesman laying here in these two pictures. Membranes are easily damaged by the trades, and it would have not taken much to compromise the system as one whole, either by uneven concrete or even an accidental tear during installation. And at that point, when water gets in, it causes major issues, as we've seen for the last 6 years. The 2 inches of rigid installation over the drainage panels also could have been damaged, which only exacerbated the issues.
Speaking of exacerbating issues, there was inadequate sloping of the soil above the tunnel itself. As you can see in the picture, the water would be funneled down towards the area on top of the tunnel, and it would be best if that was graded the opposite way, where water would be directed away from the tunnel. So that just means there's more water that could potentially intrude and also prevent proper soil draining. Moving on to the cracking and faulty joint sealant. First off, another major problem was the grading inside the tunnel itself. It was designed to have a quarter inch per foot slope to direct water away. As we can see, this was not properly executed, leading to water pooling in the center of the tunnel, as you can see on the photo in the right. There's also cracking along the walls and joints due to faulty sealants that degraded over time or were improperly installed, allowing water to seep in during heavy rains. On the photo on the left, you can notice the efflorescence, or that white marking, which is minerals deposited via the water intrusion, seeping down through the ceiling, suggesting that water is entering through the roof or the ceiling, and there could be a membrane failure or a joint failure up towards there. Moving on to the subgrade drainage issues. So the subgrade drainage systems were found to be clogged and damaged. So if you look at the bottom right and the left of that diagram, that should drain the water out that seeps down, but when they're clogged, water would come back up. If you notice, you'll find the waterproof membrane, I believe it's the second layer there, wrapping around the tunnel. It doesn't wrap around the footing at the bottom, which is a problem on its own for water intrusion, but that's exacerbated by the water that's pooled there causing hydrostatic pressure when that drainage system is clogged. Finally, the downspout location. So unfortunately, that downspout is located directly on top of the tunnel. Heavy rains virtually guarantee that water will seep into the soil above the tunnel. That, combined with the bad grading of the soil around it, means a lot of water is going to pool there and seep down onto the tunnel itself, testing the waterproof membrane. As we know, it failed that test.
To summarize the findings from our investigation, the cause of water infiltration is the failure of the waterproofing membrane system, which was either improperly installed or damaged during construction. And this allowed water to penetrate through the cracks and joints in the walls, particularly at the footings. And subgrade drainage systems that were either clogged or damaged exacerbated the issue by allowing water to accumulate around the tunnel instead of redirecting it away. Additionally, the grading inside the tunnel was not done according to the design, which caused water to pool in the center. Cracks in the joints due to degraded or poorly installed sealants also facilitated water entry and exacerbated the issue. Finally, the location of the downspout, which directed water toward the tunnel, compounded the problem by exposing the structure to even more water than it was designed to handle. And these issues together made the tunnel highly vulnerable to water infiltration and leading to this need for significant remediation. For remediation, we recommend several key actions to eliminate the current water infiltration and prevent future water infiltration. First, the waterproofing membrane should be completely reapplied. This will involve excavating around the tunnel and ensuring the membrane is installed properly without any gaps or damage, particularly at the footings. Next, we suggest replacing the subgrade drainage system. This new system will redirect water away from the tunnel before it can penetrate the structure, providing a defense against water buildup. Then we will reapply joint sealants to address the cracks in the walls and joints that are allowing water to seep in. While this is less invasive, it's important for preventing further leakage. And lastly, improving the grading around the tunnel and repositioning the downspout will help ensure the water is directed away from the structure. This will not only address the current issues, but also reduce the risk of future water infiltration. These combined solutions will solve the water issues in this utility tunnel. And thank you for hearing our proposal.
Those are the final findings for our BBM. Please let us know if you have any questions. Thank you.